Okay. Well, hello, kids. For period D, it's Wednesday afternoon. For period A, I think this lesson you're getting in class, but I'll post as a backup anyway. I can't keep track. I've been holed up in this room since Thursday, actually Friday, and I'm planning to be back on Wednesday. So period A, I saw you in school on Wednesday, I think. I've been cleared by Mrs. Geary, but period D, I won't, you're watching this Wednesday, and then we drop Thursday, and I'll see you on Friday. So poor period D when video drop, and then Friday is your test. Yes, that test on rational expressions, adding them and solving them. That's so long ago. Are we going to review? No, you review. You do the review, and then we'll take the test on Friday. In the meantime, we're doing some trig. So here we go. All right, so I'm talking specifically to period D, and you had a video yesterday, Tuesday, where we discussed page 167, given two sides, find an angle, and we assigned this homework. Well, today, Wednesday, we are going to discuss page 167, 168. I'm going to teach you a new topic called angle of elevation and depression. I don't want you to be depressed. Despite my COVID, I'm not depressed, but I will be elevated once I see you again. So it's a worksheet. We're going to do problems 1 through 6. Where is that worksheet? Oh, is it that worksheet packet that I handed out to you? No. Oh, is it that bunch of worksheets that I posted on the GC that has 1 million pages? No, it's a separate one. Where is it? It looks like this. It's posted on the GC as a single worksheet. It says angle of elevation depression. And it's got a bunch of problems and even the answers at the end. Good for you. So how about do 1 through 6? But we'll get to that. But first, let's go to page 167, 168, 12, 14, 7, 12. I think I'm going to go way ahead to find that page. You can hear my voice. I'm still just kind of head cold action, you know. I don't feel terrible. Don't feel 100%, but when are we ever really 100%? You know what I mean, kids? So if you're feeling 70%, get 100% of that 70%, and that is good enough. So this is page 167, I believe. Yep. And we had 12 through 14. Here they are. Okay. So 12 through 14 was a situation where you were given two sides and you find the angle, and I call it the 3-player game. In this case, 2 sides and an angle, and 2 of the 3 have to be given. Well, the sides are given, the angle we're trying to find. So for this angle, what side combination do we have? Well, that's its adjacent, and that's its hypotenuse, so that's cosine. So you write cosine of the angle. Cosine of x equals the adjacent 4 over the hypotenuse 5. I know we already went over this, but let's do it again. You can make that, well, we're solving for x. We can't divide away the cosine. Cosine itself doesn't mean anything. The x is attached to the cosine. So what we have to do is do what's called inverse cosine. We say x is equal to the inverse cosine of 4/5. So look at that format, kids, how to go from here to here. This equation means find the angle whose cosine is 4/5. Find the angle x whose cosine is 4/5. Well, that's what this means too. X is the angle whose cosine is 4/5. So what you do on your calculator, if you're using the phone, you hold it landscape and you do 4/5. You do 4 divided by 5 will give you 0.8. And then you hit the second button. And then you see a button that says inverse cosine, and it'll give you the angle. I should do it too. Here we go. Again, with your graphing calculator, it's easy. Graphing calculator, you just have to hit, I think it's a second button, inverse cosine, and then you type in your 4 divided by 5. You can do it right like that. So let's see on my phone. Why, back in my day, we didn't have phones, we didn't have calculators. That's the truth. It's the truth. All right, how to use a phone. There it is. And I'm going landscape wise, and I'm going to go 0.8 second cosine, and I get 36.869, 36.869. Yes. Yeah. I'm back. My wife just had to tell me what she's doing. Back to share. We'll always tell you what decimal place to round to, usually the 10th place. So this is the 10th place. The next number is 5 and bigger, so it goes up to 36.9 degrees. That's your answer. Let's do another one. So number 13, for this angle, what do you got? You've got opposite and hypotenuse. So that's sine. So you write sine of x, write the equation, opposite over hypotenuse. So x equals the inverse sine of 7/13. So on my calculator, I do 7 divided by 13. I get a big long number. Big long number. Don't round that yet. Just leave it like that. Leave it like that. And now just hit inverse sine. And I get x equals 32.57, so 32.6. Hopefully that's what you got. Number 14, same idea. For this angle x, we've got opposite and we've got adjacent. That's tangent. So you write tan x equals 15/2. So x is the inverse tangent of 15/2. Getting used to it now? So on my calculator, I do 15 divided by 2, it's 7.5. And I do inverse tangent, I get 82.4 degrees. We got it? We got it. Let's do page 68. This was 7 through 12, I think. Next page. Here they are. Okay. Do we need to do all of them? Let's do number 8. So for this, oh, this one's finding a side. Okay. So here we have the angle, we have opposite, and we have hypotenuse. So that is sine, right? So here we write sine 20 equals x over 32. So there are two types of problems. There is given two sides, the ones we just did, given two sides, side, find the angle. And this, we actually did this previously, is given a side and an angle, find the side. Given a side and angle, find the other side. In this case, just sine 20 equals x over 32, multiply each side by 32. And just type that right into your calculator. Does that work? If I go, I think I've got to do 20 sine and then times 32. I get 10.9. That side is 10.9. Okay, number 9, for this angle, you've got opposite and you've got adjacent. There's the hypotenuse there, right? Opposite, adjacent, so that is tangent. So tan 49 equals 17 over x. Now you say, so when do I use tan and when do I use inverse tan? When do I use sine? When do I use inverse sine? If you're given the angle, you're using the regular sine and tangent. If you're not given the angle, like back here, that's when you eventually have to use the inverse. Okay, so to solve this for x, I'll multiply each side by x first. Multiply each side by x, so we get x tan 49 equals 17. I'm going to divide by tan 49. You say, I thought you said you couldn't divide by cosine a minute ago. I can't divide by the word cosine. I can divide by cosine of an angle. So I can divide by tan 49. So x equals 17 over tan 49. X equals 17 over tan 49. If you have a TI calculator, just type it in like that, 17 divided by tan 49 and get your number. On a telephone, you use that word telephone? Ever been, a phone booth, kids? telephone booth. So here, can I do, let's try it. I'll do 17 divided by tan, no, as soon as I hit tan, it gives me the tan of 17. So I think I'm gonna do 49 tan. So I've got that number. It was like 1.1503 and so on. I guess I can just divide that problem out. Or what if I do divided by 17? What if I do the reverse of it? I just did 1.15 over 17 and got an answer. And then I hit the 1 over x key. It flips it over. No, it didn't. Didn't work. Forget about it. Just do this. Just do 17 divided by that and you get whatever you get. Okay, let's go on to some of these lower ones here. I use trigonometry to find the values of x and y. Oh, okay. So we're going to find x and y. Oh, same thing. Which should I find first? Doesn't matter. Let's say roll for x first. Well, for x, what have I got? I've got an angle and I've got this side. So for this angle, I've got adjacent hypotenuse. That's cosine. So cosine 41 equals 28 over x. Right? Could have I gone for y first? You could have. Multiply by x. X cosine 41 equals 28. Divide by cosine 41. So your x is going to equal whatever 28 over cosine 41 is. And again, with the phone, I'm going to do cosine 41. In cosine 41, I get 0.7547. So let's divide that out. Just do 28 divided by 0.7547. And I got 37.1. I get 37.1, which seems reasonable. That's 28, seems reasonable. Now to find y, same type of thing, right? So to find y, I can say y is opposite. So I can use opposite and adjacent. I can use tangent. Or I could use this in the 37.1. I think I'll use tangent. So tan 41 equals y over 28, right? Tan of 41 opposite over adjacent. So this one's easy. Just multiply by 28 and type in 28 tan 41. And that gives you y. I shall do it. So I'm going to do 41 tan and then times 28. I get 24.3. And that kind of makes sense, kids. I'll show you why. Geometry. Remember geometry? Remember the longest side is opposite the longest angle? Well, the biggest angle. The right angle is always the biggest angle. So that's going to be the largest side, and it is. If that's 41, this would be 49, wouldn't it, to add up to 180? So the next biggest side would be this one, 28, and the smallest is opposite 41. So it checks. Let's do one more because I want to get to the new stuff. How about number 12? Yeah, let's give it some good room here. Having a good time, kids? I feel good. I feel better than I sound. We actually got a big presentation at Bill Ricker High School Thursday night. You guys know already at Bill Ricker High School that plays in the baseball, softball team. Tell them I'm coming to do the mental toughness tomorrow evening. All right, so we got to find the angles here. All right, so it doesn't matter what you go for. I'll go for X. So I've got this and I've got this. I can't use I can't use X and Y in the same equation. That's two unknowns. So side angle. So for this angle, I've got opposite hypotenuse. That looks like sine to me. Sine X equals 7 over 15.3. Potential span. So I got distracted. So this is inverse sine, right? So you write sine X equals 7 over 15.3. So X equals the inverse. Anytime we're solving for an angle, it's inverse of 7 over 15.3. So I do 7 divided by 15.3 on my calculator machine. 0.4575, leave that big long number and then just hit inverse sine. 27.22. So this angle is 27.2. Now to find the other angle, geometry again. If this is 27.2, I just do 90 minus 27.2. Right, the two acute angles of a right triangle have to add up to 90. So what's that, 62.8? Yeah, you don't have to use trig for that one. That's it. All right, on to angle of elevation and depression. These are word problems, but to solve the word problem, you do what we just did. Here it is. No. Getting closer. Here we go. All right, let's try one like number one. Brian's kite, you know Brian, he likes to fly kites, is flying above a field at the end of 65 meters of string. If the angle of elevation, let's move me, to the kite measures 70 degrees, how high is the kite above Brian's head? All right, these all involve making a right triangle. That is my promise to you, that each one of these involves a right triangle. So let me get a right triangle. Oh, that's not a right triangle. That's not a right triangle. That's a right triangle. So this will be on your final exam, kids. Which is a right triangle? It's not this. It's not this. It's this. Very good. All right. So what do we got? I guess the kite would be here, right? So let's make that K for kite. Where's Brian? Brian's here. This is the string. And this is nothing physical. This is just the height of the kite. And this is how far Brian is from directly below the kite. So it says the end of the string is 65 millimeters, not millimeters, idiot, 65 meters long. It's a long kite. So that's 65. If the angle of elevation to the kite measures 70 degrees, that's this angle here. So let's talk about angle of elevation and depression. Here we have the ground horizontal. Here we have you. That looks like you, doesn't it? And you're looking at an object that has some height. You're looking at the kite. You're looking at your friend who's calling you from this balcony, you know, Romeo and Juliet style. You're looking at the top of a tree, whatever it is. When you look at elevation, I'll move your eyesight down there. You are creating what's called an angle of elevation. And if I drop a vertical straight down, we get a nice right triangle. Well, the angle of elevations is always formed, kids, by the line of sight in the horizontal. An angle of elevation is always formed by the line of sight in the horizontal. Well, that would be this angle here. So that's your angle of elevation, because it's formed by the line of sight and the horizontal. Make sense? So if, again, you were here on the ground and there was an object up here, I missed, then what is my, hey, how come that won't move? What is my angle of elevation? It's line of sight, which is this, and always the horizontal. So this would be your angle of elevation. All right, how about angle of depression? Anytime there's an angle of elevation, there's also an angle of depression. Let me get a right triangle here. I guess that one's okay. So once again, you get an object in the sky. You're looking at the sun. Don't stare directly at the sun, kid. You should know better than that. And here's you. So put on your dark glasses and you're looking up at the sun. Where's your angle of elevation? It's line of sight, LOS, line of sight, and horizontal. That's your angle of elevation. Angle of depression is someone's looking down from the sun. Probably not a good example. If you're looking down from the sun, the angle of depression is also line of sight with a horizontal. So here's the big mistake. people say, oh, this must be the angle of depression. No, his line of sight, that's not a horizontal, that's a vertical. That's not an angle of depression. The angle of depression is this. Make sure you got that straight. That's a biggie. Angle of elevation, angle of depression is always line of sight and horizontal. Easy to remember, always line of sight and horizontal. Now, speaking of geometry, you guys remember this? In geometry, two angles in a transversal, what were these two angles called? If you're saying alternate interior, you are correct. There are alternate interior angles, and alternate interior angles are congruent. So the angle of elevation is congruent to the angle of depression. That's always, always true. So in this picture, in this picture here, if we were looking up at an angle of elevation of 48 degrees, the angle of depression is going to be 48 degrees because of alternate interior. Come on, that's also going to be 48. Or you can use your geometry and say, okay, I know in this right triangle, if this is 48, this must be what? 42, because they add up to 90. If that's 42, then that's going to be 48 to make a right angle there. Make sense? So let's go back to the problem. So we have the kite Brian line of sight in horizontal makes 70 degrees. That's 65. What do they want us to find? How high is the kite that Brian said? They want us to find this X. Look familiar? Now it becomes just like yesterday's homework, kids. You've got two knowns and unknown. You've got opposite hypotenuse, so it's sine of 70 equals X over 65. So it's 65 sine 70 equals X. Don't need inverse sine here because we're solving for side. Inverse sine is all when we solve for an angle. So just punch that in and you get the answer, and the answer must be 61 meters. All right, let's find another one. How about one that I didn't assign? Number 8. A 14-foot ladder is used to scale a 13-foot wall. At what angle of elevation must the ladder be situated to reach the wall? So I understand a problem like this. I had the other day to go up the side of my house and fix a loose shingle on my roof. So this is the side of the house, and I had to put the ladder. And we know how it works. If you get the ladder at this angle, it's going to slide down. It won't stay up. And if you get it at this angle, that's not an angle. If you get it at this angle, that could be too steep and you're not stable. So you got to get it at the right angle. And me being an expert ladderist, I was able to do it and live another day to talk about it. So whatever that angle is, we formed our right triangle. Okay, so it's a 14-foot ladder. Which of these is the ladder? Well, this is the ladder here. Used to scale a 13-foot wall. Well, it would make sense that this wall height is shorter than the ladder because the ladder is the hypotenuse, isn't it? At what angle of elevation must the ladder be situated? Well, as I put up my ladder, here I am. This would be my line of sight for my landing point, and there's the horizontal. So that's the angle of elevation. So what have I got? I got opposite, hypotenuse, I've got sine. So sine X equals 13 over 14. I'm solving for an angle, so it's inverse sine of 13/14 equals X. And just get 13/14, second inverse. Let's just for fun see what we get, because I like doing this. 13 divided by 14, and then I do inverse sine. 68 degrees, 68.2. 68.2, Yes, look at that. We know what we're doing. Do we? Do we really, kids? Let's find out. How about one more? I'll find a good one here. Why don't we do ones you have to do for your homework? Why don't you try number 6, an angle depression? Go ahead, you do it. You can pause and come back. All right, we're back. And what do we got? From the top of a vertical cliff, there she is, top of the cliff. The angle of depression of an object that is level with the base of the cliff. Here's the base of the cliff. Here is the object. So from the top of a cliff 40 meters high, we look down at this object. Correct? Its angle of depression is 34 degrees. So this is 34. Wait, what? Wait, is it? No, it's not. That's not 34. Because angle of depression is formed by the line of sight, which is the Poiple line, and the horizontal. That's not, this horizontal is here. So the 34 is going to be here. Line of sight, purple line, and a horizontal. That's your 34. Or you could say, or you could have done this and said, well, I know the angle of elevation equals the angle of depression. If the angle of depression is 34, this angle of elevation is 34. So you put 34 there. Or you could have said, if this is 34, this is 56. So different ways to do it. But that's the triangle you get. So the question is, how far is the object from the base of the cliff? They're looking for this object from the base of the cliff. So you can use, you got to use the X and the 40. You can use the 34 or the 56. If I use the 34, well, hopefully you already did this. You get tangent 34 equals 40 over X. If you use the 56, I'd have tangent 56 equals X over 40. That's interesting. If I use the 34, opposite, adjacent, 40 over X. If I use the 56, opposite, adjacent, X over 40. This one's easy to solve. Just multiply by 40. So you get 4 tangent 56 is equal to X. This one, you have to multiply by X and then divide by tan 34, right? No biggie. So X equals 40 over tan 34. So either of these, oh, this, come on. This will give you the correct answer. This will give you the correct answer. Oh, I'm sorry, up here, actually. I'm losing my grip here. 40 tan 56, right? That one more time. Multiply by 40, you get 40 tan 56 equals X. If you do that out, you get the correct answer, which is 59.3 meters. All right, kids, that's it. So period D, I will see you boys and girls on Friday. We'll take the test. Period A, hopefully I saw you Wednesday if I'm feeling good enough, and then we'll go from there. So thanks for your patience, this kids. Wasn't my plan. I think I probably got careless. I probably should have kept a mask on, like doing extra help and all that. I'm not sure where I got it. My son got it, but he's okay. My wife didn't. And see, you know why? Because I socially distanced from my wife. You know what that's called, kids? It's called being married for 46 years. All right, see you next time. Bye-bye.